Hey everyone, welcome back to the Cura tutorial series. For those who've been following along, you'll know this is the third in the series where we begin to go over more advanced settings. And to be honest, I'm not sure exactly how far we're going to get today, other than we'll probably try to cut it off at about 15 minutes and then continue after that in the fourth series. This is the first video that you're watching. There are actually two previous, one on setting up a brand new machine in Cura 2.1, one that's not pre-configured, and then a second one on the basic settings required to get a successful print. Alright, let's get started. So, quality, as we talked about in the previous video, layer height's what's most commonly talked about, and that is just how thick each Z layer is, and initial layer height. Now, line width is configurable per feature, and by standard, it'll just be your nozzle width. So, I'm using a 0.3 millimeter nozzle. You might be using a 0.4 or 0.5. And by default, everything is 0.3. Now, top bottom line width, I actually have that set to 0.4, and so what that does is it over extrudes slightly to make the first layer a little easier to lay down, a little more likely to stick to the bed, and the top layer fill a little more smoothly. That is something that I would definitely recommend. And so, for example, if you're using a 0.4 millimeter nozzle, you might want to go to 0.5 millimeter top and bottom line width. Now, these other options are places where you can specify a slightly larger or smaller width than the actual nozzle diameter. And if you're trying to print something with great detail, and you're more concerned with the cosmetic appearance than the strength, you could actually specify a slightly narrower line width than your nozzle is. Likewise, if you are going for better interlayer adhesion, you could actually select a slightly larger line width than your actual nozzle is. I would say that 95% of the time, the only one of these that really should be modified is the top and bottom line width. That's where you're going to see the greatest benefit. And if you are looking for a different performance from your printer in terms of the nozzle size, it's probably better just to swap the nozzle out with an actual different size. So I'm using a 0.3 because I print relatively detailed items with this printer. And perhaps you want to print faster, so you might even go up to 0.5. But in general, the line width should probably stay what your nozzle diameter is, unless you have a very specific need for changing it. Alright, let's go on to shell. Alright, so we've already talked about wall thickness. Everybody should be comfortable with that concept. We've already talked about top and bottom thickness. Top and bottom pattern. Now I'm going to go into the slice view for this part here. So we'll let Cura think about that for a minute and slice it. The top and bottom pattern is the method or the path in which it will fill in the top and bottom of your model. So I'm going to do one quick thing here just to make slicing a little bit quicker. For all of this, we're going to change this to 0.3 just to speed it up a little bit. Okay, so I've swapped in just a simple test cube for this next section just to make updating faster. This will change the way in which it fills in the area inside of your perimeters in the solid portion. So, as you might imagine, lines means this is going to go back and forth, side to side. Concentric means it'll keep going around and around and around and around and around until it gets to the center. And then zigzag will actually go parallel to the walls, over and then back. These are very nitpicky settings. Most of the time, you won't notice a difference between the outcome of your print when choosing these. There are some times, for example, with concentric, with a symmetrical item, where you'd like to have that top and bottom pattern just be perfectly symmetrical with the item. You don't want lines breaking it up. That's one that I could see. Zigzag, I've literally never used. But hey, if you want to play around with it, sky's the limit. Alternate extra wall. This is a great one for people who are working on building something that's mechanical in nature and they want to get a little more strength out of the part. And what it'll do is every other layer, it will put an extra perimeter, an extra wall layer down, and it will sandwich the infill beneath it. It'll basically sandwich that infill connecting point, and it will create a stronger print as the result of it. If you're just doing something casually, or it's a cosmetic print, it's probably not necessary. But it also doesn't really hurt, aside from the fact that it might take a little extra time to print that extra wall. Remove overlapping inner wall parts. I don't remember if we touched on this briefly in the last video, but this is a good idea. It basically removes areas where the nozzle will extrude over the same area twice and end up with over extrusion, where you might see a little bulge or a little artifact because of it. So I would pretty much by default leave this guy checked. And then fill gaps between walls. So after overlapping inner wall parts have been removed, it will fill that gap, and it can make the part stronger. So there's pretty much no reason not to use this everywhere, although you can tell it to not do it at all, or to only do it on the skin or the outer portion of the model. But unless you thought there was some anomaly in your print that was being caused specifically by this feature, I would probably leave it set to everywhere. Compensate wall overlaps. This is very similar to remove overlapping inner wall parts. Instead of intentionally not extruding there, however, it will simply reduce the flow so that the combination of the two nozzle paths should result in 100% extrusion as opposed to 150 or 200% extrusion in that area. So I typically prefer to have it just remove that path rather than just reduce the flow. Horizontal expansion. This is very similar to a Simplyify 3D feature for basically increasing or decreasing the tolerance or the gap around features in a print. This is specifically useful for hinges that are supposed to be printed in place, and if you're having an issue with that hinge being stuck together whenever you're done with the print and it's not actually moving, and you end up breaking the part trying to get it to move, adding a little horizontal expansion can loosen that up. Or if you have one that's too loose, you could actually put a negative number in there and shrink it down a little bit to make it tighter. Be aware that if you do this, you are going to affect the total part tolerance. So if this is a mechanical part that needs to be very specific in dimensions in other areas, doing this will affect everything. So in those cases, it's probably better to go back to the original model and make it, or file, and make an actual change to the file. But for things like you know, a filament cleaner that's supposed to hinge or clip, it'd be perfectly fine. Or any other type of, you know, character model or something that has a joint in the arm or something like that, and the actual dimension isn't that critical. Using this to fudge those gaps a little bigger, a little smaller, is a great way to do that without having to have the source file and be able to modify it directly. Z alignment. This is a really big one. A lot of people notice Z issues, or Z scarring as it's sometimes called. And essentially what this does is it gives you some options for how you handle your Z seam alignment. And when they say Z seam, what they're referring to is every time the nozzle changes layers or goes from one layer to the next, there's typically a little gap and sometimes a little bit of over extrusion where you'll see a little bump, and it'll look kind of like a seam if they're all lined up, or it'll look kind of sporadic if they're not. And what this option does is it gives you the ability to determine if you want all of your seams to line up, if you want it to intentionally randomize it, or if you simply want it to just optimize it for speed. So it will change layers wherever is the most convenient, as opposed to intentionally modifying where the layer changes occur to follow one of the other rules. So I typically do shortest because the Z seam, when minimized by some of the other settings, isn't all that noticeable, and if it's a mechanical part or something of that nature, then it's really irrelevant to me. However, if you know that you're going to be sanding and painting a model, having it put all of them on the back of the model, all in a row, could be very nice, because you can come along with a knife, trim that seam flush, do a little sanding, and then you can get rid of that seam in short order. If it's a model that you don't want to do any post-processing on, and you just want to use it as is, doing random can help disperse those Z marks, those layer changes, and make them less noticeable. And then if you're just interested in speed, shortest, obviously, would be the option that you would want. And then this final one has to do with small gaps in the model that are in the z direction. And basically what they're saying is that if there's very small gaps, it can just ignore them and not even try to define them, and it will save you time during the slicing process. And typically these gaps would be so small that your printer may not even have the Z resolution to actually define them. So by ignoring them, it doesn't change the quality of the print, and it saves you some time in slicing. So I typically leave it checked. If you have a really small Z feature you're trying to capture and you think this setting is interfering with it, then uncheck it and see if that changes that issue for you. But in general, the size of the gaps would be so small that you probably wouldn't be able to actually print them anyways. So that is everything in the shell category. All right, moving on to infill. Again, this is something we've obviously touched on the primary factors in here, which is density, which determines how much plastic goes on the inside of your model. We maybe talked briefly about pattern last time, but let's talk about it again really quickly. So there are several different options. Concentric, as we'll see here in a second, just puts all of the infill at that percentage, concentric around the center of the model. Grid, as we just saw, is the default, and it's just a crisscrossing pattern. It is pretty easy on your printer because the printer goes all the way to the edge of the model before switching to the next line, and it doesn't put a lot of stress on the printer's motion components. And actually, by that matter, concentric can also be pretty low stress on your printer because it's just going around in circles. Lines takes all of the infill and just puts it in one direction, typically at some orthogonal angle with respect to the rest of the model. And it is quicker than grid, but it's obviously not as strong. So if it's a mechanical model, a functional item, you probably don't want to use lines. And then triangles is a cross between grid and something like hexagons or octagons, which other slicers have. It is designed to be stronger, probably the strongest, but it requires a little more printer time. It also doesn't normalize the infill pattern to the part. And in fact, actually, this is true with I think all of these. The infill patterns normalize to your bed. So if you were to move your part around, you would actually be able to fill the model in a slightly different pattern. So because of that, you can have some non-symmetrical endpoints in your model. If you look at this one, you know, we have a lot of triangle points ending in this corner. We have almost none ending in this corner. So in general, it will probably be stronger, but it can also look a little bit strange depending on how the pattern fills out inside of your model. And then finally, we have zigzag. Zigzag is kind of like lines, except instead of just starting and stopping at the wall, it actually connects each line from side to side. So it's sort of like one continuous thread of infill. It's a little bit stronger than lines, but still not as strong as grid or triangles. Okay, while we are in the infill topic, I want to show you guys one other feature that is new in Cura 2 that I think a lot of people miss, and is actually something that is very well known for Simplyify 3D, and that is multiple options per item, or per single print. So for example, I have gone through and I've selected different infill patterns for each of these, and to do that you would simply select the object, click on the per object settings, and add a setting. So I've already added a separate infill pattern. So if I go to my slice, my layer views here, we can see that I've selected different infill patterns for each of these, and for this one I've selected a different wall thickness. Another thing that we could do, we could go into per object settings, we could add another setting, we could go down to material, and we could actually tell to print it at a slightly different material. This is very powerful if you want to test out a new material and you want to quickly check how it performs at a wide variety of temperatures. So you could print 4 cubes, you could print them at 4 different temperatures in 5-degree increments. You could check out how the material responds to different flow rates. So you could start at 95%, 100%, 105%, 110%. See how that impacts it. You could test all your retraction settings on a single print by changing the retraction speed or the retraction distance. So this is a very powerful tool, both for troubleshooting and optimizing, but also just for practical things, like if you want to print 4 different items all at once, and you've got some large, low detail items you want to print relatively fast with a low percent infill, and then you've got some high detail objects you want it to print slower. So we could go down to print speed, and we could change our print speed for every item. So we could have a high detailed object that it slows way down to when it gets to, and then a coarse object that it speeds way up to when it gets to. This is incredibly powerful. Now, if you're using a monoprice select mini, like I'm using for this example, you probably aren't going to load your print bed up with more than a few things, because there just isn't room for it. But for anybody watching who's got a larger, maybe Prusa i3 design, or something with a an 8x8 or an 8x10 bed, and you can put a lot of items on there, being able to customize every single item in there to maximize its print quality and minimize the print time is incredible. Now, the one limitation is that it still forces you to have the same layer height for each object on the plate. So you can't print one at 100 microns and another one at 300 microns. And while it's technically possible, in fact, I believe Simplyify 3D's version of this feature allows you to do that, it does introduce some complications in that you can have parts printing at different rates, and you'll have one object that's some multiple of microns higher than another item, and there's some ways to solve that problem, but I think that they decided to just limit the layer height to a single option for now, and we'll see if in future releases of this multiple objects, multiple settings feature, if they begin to allow you to differentiate layer qualities between items. But even without being able to do that, there's a million things you can do that are incredibly useful with this feature, and I've heard almost no one talking about it, which is surprising due to how powerful it is, and how much value you can get out of it. So that was a big one that I wanted to touch on, and while we were talking about infill, it was kind of a natural segue. A couple other things down here under infill that we didn't talk about in the basic settings video. Infill overlap, that basically determines how much the infill will overlap into your printed wall, your printed perimeter. And this basically determines how strong the infill bonds with those walls that you have printed. 10% is a good number. If you feel like your infill is breaking free from your walls, you could bump that up a little bit. If you are making a very cosmetic print with thin walls and you didn't like seeing that infill running into your inner wall layer, maybe if it's transparent material, turning the infill overlap down or even off is certainly an option. Although in those cases, I typically recommend that people actually set their infill density to nothing at all, 0%. And as long as it's not a large flat-topped item that would have to bridge the entire top, you can actually print figurines and other models very cleanly, completely hollow, just with the perimeter walls. Infill wipe distance. This is very similar to overlap, except what it does is instead of driving the extruder while it's going into the wall, it actually stops the extruder and allows the pressure that has built up in the nozzle from printing to extrude a little bit of material as the nozzle passes into the wall. I think it's a good option because it helps create cleaner retractions. Because when you go to do the retraction after having done infill wipe, you have less pressure in your nozzle already, and you'll have less likelihood of oozing whenever you are passing from one part to the next, or one feature of the part to the other feature of the part. You can specify an alternate layer thickness for your infill. So for example, if I was printing at 150 microns, I could set my layer thickness for the infill to 300 microns, and then I would only print infill every other layer. It would basically print 2 layers worth of infill at a time, and that's definitely saves time, and is a pretty good option if you're looking for ways to tweak your overall print speed performance. All right, and then the last feature in the infill category is infill before walls. and essentially you can tell it to either print the infill first, which can lead to sturdier walls and better overhangs, or you can tell it to print the walls first, which can lead to perhaps a cleaner looking exterior, but it may not be as strong. So that's kind of a toss-up in the air. And on a lot of prints, you may not even notice a difference at all. But those are kind of the two items hanging in the balance on that option. Okay, guys. I think that is probably going to make a video, and I think the continuation will happen in the next. So we'll start off with materials next time, and keep moving on down the list. I hope these videos are useful. Let me know in the comments if there is something about the way that I'm doing the videos you'd like to see me change slightly, or a feature that we've already talked about and there was something that didn't make sense or I didn't explain clearly. Please let me know. I can always touch on it in the next video or address it in the comments. Alright guys, thanks again for watching, and we'll see you in the next one. Bye.